everybody. So today I'll talk about the transformations and vectors in BitByBit, and I'll just join those two categories into one video so that first of all, they are related, of course, but I will mostly concentrate on transforms because that's the concept that we will be using a lot in BitByBit. To just show you what the transforms are, I can open the category, and you see that we can apply various transformations on all kinds of objects. So these are all the possible transformations that we can apply, and we do that with components that are usually laying somewhere in the apply section of the categories of geometric entities. So you see that we can transform the point, we can transform multiple points by a transformation, and transformation always comes from this transforms component. And we can do that also for line, so transform line with transformation. We can do that with polyline, so we can transform a polyline, a curve. It's somewhere here, so you can transform curves, and you can also definitely transform the surfaces with these transforms. So it's super easy in BitByBit to do that. What you need to keep in mind though is that those transformations are usually dealing with various kinds of scaling factors, and it's really important to realize what your transformation, what are the reference points, and how that all fits together in your script. But let's without further delay, let's try and apply those transformations on for example, a list of points, and I will use the spiral of points as a basis for the transformation. And to do that, I will also just call my grid. I will make it white and gray, and then also I'll make the scene background to be dark so that our eyes can adapt better. And let's for now kill spiral. Let's make this initial setup. And now let's create the variable for spiral points. So we will just do spiral points text here, and we created that. We can attach all the spiral points to this variable, and we may as well just draw those points. Let's find the variable, and let's pick a color yellow. Yes, so here's our spiral, and that's an original spiral that we have. Oh. So good. Now the next thing we want to do to show what the transformations can do is we just take the scale with, well, maybe let's try the uniform scale first. So if I take the spiral, this is the original, I will increase the amount of points to 500, for example, to see better how that all works. I will also ask the point to transform points, and I will use this transformation, and I will also use the spiral points as an input here, and I will also draw those transform points with a slightly different color, and I'll just pick red, for example, and let's throw that out, and let's see what happens. Okay, so exactly as expected, our spiral was just scaled 2 times. So you see that it went with the scale of uniform factor 2, and it got twice as big. So that's how the transformations work. And this component just produced another list of points that can be again drawn in space. So this is the most simple probably example of the movement of the transformation, and you can find here other things like move by XYZ vector. So if we move our spiral by that amount, you will see that it will go and be drawn in a different, it will be just moved into another place. So this is quite fun because we can begin doing things and play around just like by making those lines in between those 2 spirals. Draw lines, mesh with lines, and I'll create. So if we also make a transformed spiral points variable and assign that here to transformed one, we may begin seeing quite nice results of transformations. Let's find the variable in the list. So let's draw that transform spiral, and let's use this and spiral points to make lines that go between those 2 spirals. Yes, so this is more 3-dimensional result of the transformation, and you see how these 2 things map on each other now. I'll just create that color to be a bit more easy on the eyes. Yes, so we now transform by moving on XYZ vector. We can check what other kinds of transformations do we have, and there is also of course the rotations. We can rotate around axes, various axes. We can rotate around standard x-axis in angle of 45. We can also basically we can also stack those transformations in the pipelines. So we can say we want to transform points by moving them and rotating also. So I will just do that now as well. So first I will rotate the spiral in 45 degrees around x axis, and the center is 0, 0, 0, so that's okay. And also I will then find the transform points component again, and I will use that. So I will transformed result by moving it with the same direction but then rotated, and we will see what kind of result do we get. So this time we see that it created this well, it rotated the spiral 45 degrees as we've asked around the x-axis, and then it also shifted that by the 2 to 2 vector in diagonal 3D space. So these are quite a few examples of transformations. You can always of course play with the numbers and say what the effect would be if I do this, and well, it's all up for grabs. But one thing I wanted to also mention in this video is this list of components that are that provides us with all kinds of standard vector operations. You can measure angles between angles, distances. The vector itself is of course just a direction indication with a magnitude, and you can transform vectors into unit vectors. Well, that's just, this list is quite vast of what you are able to compute. We will be using those quite a lot in further videos, so I'm not going to go in depth here, but you can also use these vectors in combination with transformations, so you could create really interesting results, animations, and all sorts of things. So I hope you enjoyed this video. I hope you did understood the concept of transformations, and thanks for watching. Please subscribe. Bye.